video, we'll talk about parabolas and the maximum and the minimum. I've graphed two parabolas for you here showing the vertex. And we know from previous lessons that the vertex is the point at which the parabola turns around. It is also the minimum or the maximum. It's clear to see on a parabola that's facing up like this that this is the lowest value, and that's why it's called the minimum. When the parabola is upside down, the vertex turns into the maximum. So there's two little things you have to keep straight about this max-min idea. The actual max or min value is the y value. The x value is where the max or min occurs. So take a look at this vertex right here. This is the vertex 2, 1. The actual minimum value is 1. The minimum refers to the y value, but it occurs at x equals 2. This vertex is the point 0, 2. So the maximum height it reaches is a height of 2, that's the y value, and that occurs at x equals 0. Here's a parabola I've already graphed for you, and I've indicated what the vertex is from the graph. Does this have a max or min? Well, looking at the picture, it's pretty obvious that it has a minimum. To name the max or min, remember that is the y value, so the minimum is -2. And the reason the minimum or the word max refers to the y value is that there is no minimum x value. Remember, your domain for the parabola is -infinity to infinity. It is all real numbers. There's no way we could name a minimum. So the minimum refers to the y value. And where does it occur? The corresponding x value, which is -1. So the max-min is the y value, and where it occurs is your x value. And that was pretty easy to name using the graph. But now we want to do the same thing with an equation and see if we can name this same stuff without using a graph. Of course, you could always graph it on your own, but this really isn't bad. We want to answer the same questions about this function that we did on the previous screen, but notice there is no graph drawn for us. So does this have a max or min? You should recall the max or min refers to, is it facing up or is it facing down? This is facing up, so it has a minimum. How do I know it's facing up? Well, the coefficient right here that's in front of the parentheses dictates the up or down facing. The coefficient that's in front of these parentheses is a 1, which is a positive value. Since that's positive, that's what tells me it's facing up. Now we want to find the max or min. Well, the max or min is going to occur at the vertex. The vertex of this parabola is 3, 2. And we know that that occurs at the y value. So vertex was 3, 2. The y value of the vertex is 2, so the minimum is 2. And where does it occur? It occurs at the x value, which is 3. So the minimum occurs at 3. We also have to be able to name the domain and range for these functions. Again, you can make the picture if you want, but you really don't have to. The domain is very easy. The domain of all of these parabolas is all real numbers, which is -infinity to infinity. The range is 2, infinity. Now, where does that come from? There's a formula. The formula is this. The range will be your y part of the vertex, which is actually k. Remember, your vertex is of the form h, k. So the range is k, infinity because it goes to infinity, and of course, that's the curve. And then here's the graph for you just so that you can verify that our information is correct. There's our vertex of 3, 2, and our range is going to be the lowest value of 2 and goes on up into infinity. New equation. Let's take a look. Does it have a max or min? Well, which way is it facing? Because that's negative, it is facing down, so we know it has a maximum. Find the max or min that's going to occur at the vertex. The vertex is -1, 2. So that the max, which is what we decided back here, will be at 2. And where does it occur? It's going to occur at the x value of the vertex, so it occurs at -1. So max and min is very easy to name. If you can name the vertex and understand how the parabola opens, then you can name the max or min and where it occurs. Let's take a look at domain and range. Domain is your simple -infinity to infinity. Now the range is going to be a little bit different because this parabola is upside down. This range is going to have a minimum y value of -infinity and go up to a maximum y value of 2. So here's the domain and range written a little bit more neatly. This formula-wise would be negative infinity, comma, k. That's what your range will always be if your parabola faces down. Take a look at a picture to verify. Our vertex is right there. There's that negative 1, 2 we've been using. The height, the maximum height it achieved was 2, and that occurred at the x value of negative 1. The domain, of course, is negative infinity to infinity, and the range, you're tempted to start at the 2 because it's drawn this way, but your range has to begin at your lowest y value, which is negative infinity, and it reaches a height of 2. That was negative infinity, comma, k. And k does get the square bracket, and negative infinity gets the curved. So here's just a conclusion about your domain and range. If you have your function in standard form, then to name the domain and range without graphing it, the domain is always negative infinity to infinity, so that's easy. Your range depends on if it opens up or down. If it opens up, the range is the k value, comma, infinity. If it opens down, the range is basically the opposite, but don't forget to put the negative on that infinity. There's one type of word problem we're going to look at that involves this area stuff, and it's this. You have 200 feet of fencing to enclose a rectangular plot that borders on a river. If you do not fence the side along the river, find the length and width of the plot that will maximize the area. When you see the word maximize or minimize, that says we're talking about a parabola and we're talking about finding the vertex. Of course, when you get to calculus, there's other ways to find max and min, but for us, it's a matter of finding the vertex. So there's my little river. Here are the values that are going to be on the length and the width, and those are given to you in the book, but perhaps they're not given to you in other problems, so let's look at where they came from. I've got to call one of these values x. Doesn't matter which one I chose, I just chose that one to be x. If that's x, this one's x. This comes from the fact that we had 200 feet of fencing. 200 feet of fencing, take away these two sides, is 200 minus 2x. That's where those values come from. We want to maximize the area, which means we need to have an area formula. Area is just length times width. For us specifically, we're going to have this times this, x times 200 minus 2x. Let's finish this out. Distribute the x through there, and we will get 200x minus 2x squared. Now there's two things I'm going to do on this next step. One is put y in here instead of a, just because you're used to having x and y in the equation. The other is switch this order around so that the x squared is first. And the reason I want to do that is that I need to find the vertex. Remember, we're trying to maximize this area, which says find the vertex. The vertex is very easily found by using the formula negative b over 2a. So this is my a, and this is my b. And if I hadn't swapped those around, we might have gotten our a and b confused. So that's why I swapped them around. And then I just have to do negative b, so it's negative 200 over 2 times the a value, which is negative 2. Negative 200 over negative 4 is 50. So my x value is 50. That means that is the width of this rectangular field. All I have to do to find this dimension is plug the 50 in for x. This will be 200 minus 2 times 50. 2 times 50 is 100. So this is just 200 minus 100 is 100 feet. And you can check, does that really use up the 200 feet of fence? Yeah, because that's 50. That's 50. That's 100, makes the 200 feet of fence. Now, find the length and width of the plot. We did that. It's a 50-foot by 100-foot plot. But it also asks, what is the largest area? Well, area is just my length times width. So 50 times 100 would be 50,000 square feet. I'll write it this way, feet squared.